Hello, my name is Jason Chanko, and I'm a Business Development Manager at Lakeshore Cryotronics. In today's video, we're going to take a closer look at the Model M81 modular test system, the MeasureLINK software, and the M81 LED demo board. In this case, we're going to need the following hardware. We'll need a M81-4 or an M81-6, a current sense module, that would be CM10, a voltage measure module, VM10, a voltage source module, BS10, and a balanced current source, or BCS10. So the following will be connected to the rear panel of the M81 mainframe. That's going to be the BCS10 in slot 1 or S1, voltage source 10 or VS10 in S2, the VM10 in M1, and then the CM in M2. You're also going to need a USB Type B connector or cable to run from your controlling computer to the instrument itself. You'll also need MeasureLINK software and the applicable demonstration sequence and the LED demo board. The LED demo board will be connected to the VS10 on the left-hand side of the board, connected to the LED itself, and that's going to be the drive voltage for the LED. And then we're going to be monitoring the photocurrent from the LED using a photodiode, and we're going to be connecting with a BNC cable to the CM10 as shown in the diagram. Now that we have our hardware and our software downloaded and configured, we can start the MeasureLINK program. So we'll just start by double-clicking on MeasureLINK. That will open up the splash screen. And now we've got two windows. We've got this main window here that's going to show you home and utilities, and then we've got the instrument control panel. For now, let's focus on the main window. So we'll just click on that, and we'll click on home. And you'll see here, once we've clicked on the home tab, we've got system configuration. This is the area, system configurations, where we're going to establish all of the hardware that we're going to use in a particular sequence. And so, as you'll see, this new configuration does not have any instrumentation populated. We do have an M81 physically connected via serial to this controlling PC. So we're just going to start out by adding that hardware, pressing add, and now you'll see a list of drivers comes up. We're just going to scroll down here. We're going to connect to the the M81. This is the main test head, and I'm holding down the control key on the keyboard to select multiple entries. We're going to select the balanced current source, the current measurement, the voltage measurement, and the voltage source modules. So again, we've got an M81 mainframe or test head, and then the four modules, balanced current source, a current measure, voltage measure, and a voltage source. Once we've selected those, we can hit OK. That will populate this list. So you'll see we've got the device name, driver name, and then a brief description. Let's start out with the M81. What I'd like you to do is press Auto Connect. That's going to automatically go out and look for the instrument every time we start MeasureLINK. And this can make it a little bit easier when you're running repeated measurements or repeated demonstrations for customers. That Auto Connect will automatically connect to any instruments you have available if they are connected physically to the, if the driver and the software is all configured correctly, it will communicate directly with the instrument. So again, M81, press Auto Connect. I'd like you to come down and go to Communication. And now you'll see that it says Simulator. We can simulate many of the instruments that are Lakeshore compatible with this software, but we can also go to Serial Native. That's the USB Type B connection to the instrument using the native Lakeshore driver. So we're just going to select that for this case. And you'll see that it says port number is COM3. I'm not entirely sure if this is physically connected to the instrument, so we can press search, and you'll see that we can press refresh, and now it's saying, hey, the software does notice that there is a piece of hardware, the M81, connected to COM port 4. This is the only instrument I have connected, so let's select that, and we can then test the connection. So to test the connection, we can connect to this is going to open up the device communicator utility. We can connect to the instrument, and it says, okay, I have connected to it. And now we can send a string. You can look through the user's manual for any of the programming interface or any programming skippy commands to the instrument if you'd like. But the most relevant here just for testing is the identification string, which is *IDN query. We can write and then that's going to send the string to the instrument, and then we can read it back, the response. Here the response is going to be the manufacturer, the product name, the hardware, and then the firmware revision. Also, you can hit query, which is going to send a write and a read. So here we've sent and read the response. So again, just a nice little window that we can test the communication to the instrument on a single line command if we'd like. So now we've established connection to the instrument itself. We can now configure each of the modules for their location in the instrument. So the BCS in this example is going to be, we'll go to communication, and the BCS is located in device M81. The channel location is source 1. Let's go to the current measure. The current measure for this demo is going to be in the host device, which is the M81, and then the current measure is going to be in the measure 2 position. We'll go to the voltage measure, down to communication, pick the M81, that is going to be measure 1 location, and then the M81 VS or voltage source, back to communication, we'll assign that to the M81, and this is in source 2 location. So now we've got the M81 connected to COM port 4 to the instrument, and then we've located each of these modules in the instrument itself. Once we've established that we have all of these in the correct place, we can then save that as a configuration, and we can also apply that configuration. And so now we've applied that configuration, and if we go over to the connection window, you'll see that this slider here where it says M81 source measure system is now orange, and we're actively reading data back from the instrument. That is required, that connection is required to configure and run any sequences. So if it's in the white position, slider is over, it says not connected, then this is going to throw errors when you go to run a sequence. So again, you just want to check that instrument connection to make sure that it is connected prior to running any sequences. Now that we've verified the instrument connection, we can now go to File, and we can open one of our sequences. Well, I've already actually run some of those here, so we can go to the log I versus V sequence. It will show some existing data or previously collected data. So let's just take a step through this. So this is your first time viewing MeasureLINK. What you'll see is we've got this chart at the top that's going to be charting photodiode current versus LED voltage. We do have settings that we can adjust for those, but again, for the purpose of this demonstration, we're just going to show you what we have. So we're going to be sweeping LED voltage, and we're going to be measuring the photodiode current using the M81 LED test board and the actual LED photodiode part of that circuit. The step 2 is the current measurement or CM configuration. You'll notice that there are a number of checkboxes. Any checkboxes that have been checked are going to be adjusted on the instrument. So if the instrument has previous settings, they are going to be overwritten by whatever we have in the checkboxes. So again, current measurement, we're going to be measuring the 100 microamp range. The voltage source, we're going to be outputting a DC voltage. And we're going to be doing this starting at 0. So we can go to, then there will be a pause for 5 seconds. Then we will start the sweep. This is a discrete electrical source loop. If we click on this particular step, you'll see that there are 101 steps. It's a linear loop or linear sweep. And with a 5 millisecond delay between each point, it's going to go from 0 volts to 3.5 volts in 35 millivolt steps, and it's going to turn off the source after the loop. Now we could round trip, which would go up and back down again, but again, in this case, we're just going to go in the positive direction from 0 to start value to the end value. We'll be making measurements along the way. Again, we're using the voltage set point in the left-hand side of this column, and then the measured DC photocurrents are going to be in the right side of this column. So we can simply go back to the start of the step 2, and now we've got start. So we've got start overwrite. Start overwrite is going to overwrite the data for any sweeps. So if we run this multiple times, each sweep will overwrite the existing data, and that's okay for a demo like this. So we'll just press start and It will begin the sweeping as soon as the timer has expired. So at the very beginning, you'll notice that the data does look noisy. What's happening? The chart X and Y axes are going to auto scale. So we're at the very low end of this photocurrent. The LED is not very bright at this point in time. We're actually just measuring ambient light in the room. But as the LED begins to get brighter and brighter, it will start to auto scale, and you can see that now. And so we'll get a nice LED sweep, or light output curve, or photocurrent curve for this LED at specific drive voltage values. And now we have completed that. So you can also sweep through the chart itself, looking at individual values, and clicking on them will give you the Y value instead of just the X. And then we can save we can go over to the synchronous measurement page, and we can then export that data as CSV if we would like. So I hope this was a helpful demonstration of the log I versus V sequence in MeasureLINK.